one of the things that befalls every wastewater plant is that, especially if you're in a city, right? If you're a drinking water plant and you know that something is coming down the river, right? It's a surface water plant. You know that a tanker has spilled something nasty into the water. They can just say, you know what? We're not going to take any water in until that passes by. These water plants, by and large, don't have that luxury, right? So whatever is coming, they've got to take it. They can't tell people to not flush their toilets. They can't tell people to not pour things down the sink. It's coming. Yeah. Right? So they've got to deal with it.
You're in the water loop.
Welcome to Waterloop, the nonprofit news outlet exploring solutions for sustainability in water. I'm the host, Travis Loop. Utilities across the country are facing shifting water quality challenges, from changing influent chemistry to tightening discharge limits. This demands smarter monitoring and faster response. In this episode, Williams of Hach shares how utilities are adapting to this evolving landscape through advanced analysis and real-time data. Before starting the conversation, I want to share more about this episode's sponsor, Hach. And if you value Waterloop content, please reach out to sponsors that make it possible. Water treatment plants today face tighter regulations, unpredictable water quality, and growing staffing challenges. That's where Hach steps in with the new EZ-SC series, a smarter, simpler way to monitor water quality. Guided workflows walk operators through setup and maintenance, while reagent counters and remote alerts keep performance on track, helping teams avoid downtime and stay ahead of regulatory demands. With broad measurement capabilities across nutrients, organics, trace metals, and inorganics, plus a new grab sample feature to confirm consistency between lab and process results, it delivers accuracy operators can trust. The EZ-SC series streamlines integration with both analog and digital outputs, reduces product complexity by 80%, and supports monitoring of up to 31 parameters, all in one scalable platform. To learn more, visit hach.com.
Since you look so closely at water and you help your customers look so closely at water, very curious about trends in water at water treatment facilities. Let's kind of start at the intake side. What are you seeing with what's coming into water treatment facilities? What are facilities, utilities out there seeing on this front? Changes in the chemistry, changes in the volume. What's happening?
So, what we see coming into plants, and it could be locally variable. It could be widely variable, right? Depending on what's coming into the collection system. And so depending on the contaminants that are coming in, you could have largely domestic waste coming in. And so, there could be a combined sewer that has a storm sewer as well as domestic waste. And so that can be vastly affected by rain events or big snow melt events or something like that. And that can change the concentration of everything in the water. But then, if you're in an area that's dry or you're not in a season where you get a lot of rain, you can get things like, and this is not new, but it's something that continues to go on. You have fixtures that are lower flow. Everybody's trying to save water. People aren't watering as much, so that's not going into the storm sewers as nearly as much, or even into just the sewers that you have on the street. And so that can make everything more concentrated, right? And then that impacts the treatment of the wastewater. So things that are coming in can be more concentrated than a plant that was designed back in 1960 might have been prepared for.
How is that reflected in the monitoring?
We have multiple different kinds of samplers that can sit in not only in the influent of a wastewater plant, but even in the collection system, and sample based on time, based on flow, based on certain events. They can hook up a pH probe to, if the pH gets very extreme, then it can start taking more samples. And so then somebody can get those samples, take them to a lab, or use a portable device to do some testing on them. So knowing what's coming in, and also there's online instrumentation that you could put in the headworks of a plant, or not everything goes well in the headworks because of all the solids that come in. So maybe it's after an initial bar screen or a comminutor or grinder or something like that. But after some of the stuff has been removed so it doesn't foul up the equipment, they can do all kinds of online testing for things like pH, things like suspended solids, things like heavy metals. There's things like toxicity, right? So knowing what's coming into the plant and knowing if it has some extreme levels of some contaminant that the plant doesn't want, or more importantly, that can impact the biomass, which is basically the workforce of the plant that's getting rid of the organics, or that's converting nitrogen containing compounds ultimately to nitrogen gas, or getting rid of phosphorus. All those things that can come in and impact the plant in negative ways, they can test for at the earliest possible point in the plant. So then they'll know what to do with it.
And there's a variety of responses they'd have to take based on whatever those changes are,
Right.
flow or contaminants or.
Another thing on the water coming into the plant, right? Some plants have the luxury of having an equalization basin or some large collection tank, or even some plants will have a lagoon that might have been the treatment in a plant, decades ago, but now they can use it to put heavy loads or toxic loads or they have extreme parameters that they don't want to come into the plant. They could put it there. And by online monitoring or doing sampling where they can grab samples and test for it when it's coming in, we'll let them know, hey, we need to divert this because this is going to be really bad for our plant. And then that will, if they don't do that, that can impact all of these processes downstream.
Sure. What about inside these treatment plants? What are some of the trends, issues, things happening in the water inside?
The thing that's neat in wastewater is there's so much variety of ways that water can be treated, depending on the design of the plant, depending on what's coming into the plant. If it's an industrial plant versus a municipal plant, there's going to be different sorts of treatment that come into play. So coming into the plant, you can have nutrient removal processes, things that are biological. You can have chemical removal processes, precipitation for things like phosphorus. You can have aeration using atmospheric air and blowers. You can also have plants that use pure oxygen, right? So there are plants that use different types of disinfection, whether it's going to be chlorine, whether it's something like ozone or chlorine dioxide or peroxide, or there's all kinds of neat things that are going on in plant treatment.
And so that all is just different water chemistry across the board. Well, what does that mean for the monitoring and analysis of that water inside the plant? What kind of needs does that create? What's happening on that front?
One of the things that befalls every wastewater plant is that, especially if you're in a city, right? If you're a drinking water plant and you know that something is coming down the river, right? It's a surface water plant. You know that a tanker has spilled something nasty into the water. They can just say, you know what? We're not going to take any water in until that passes by. These water plants, by and large, don't have that luxury, right? So whatever is coming, they've got to take it. They can't tell people to not flush their toilets. They can't tell people to not pour things down the sink. It's coming.
Yeah.
Right? So they've got to deal with it. And so those chemistry things that you're talking about, they have to take in whatever they get and manage it as best that they can. If they have the luxury of something like that to be able to divert things away, that's great, and kind of bleed something back in, but not every plant has that for various reasons. So that chemistry, the monitoring the ability of the process to remove nutrients, to remove things like nitrogen and phosphorus, to remove metals, to remove pathogens, to get rid of suspended solids, and also monitor how they recycle things in the plant, the activated sludge that does the work. They have to get rid of some of it, but not all of it. And they have to be able to balance that, right? So there's so many things. And at Hach, we've got analyzers for so many of those things that they can measure. So things for nitrogen, things for phosphorus, things for different forms, nitrate, nitrite, ammonia, reactive phosphorus, total phosphorus, like lab process.
So then moving to kind of that third piece, right? Leaving a facility, the water there's new regulations all the time, new discharge requirements, or new environmental goals that a city or community might have, a facility might have. What's happening on that landscape?
Yeah, it's a great question because it feeds right from the last question you asked about the chemistry, because that chemistry in the processes, those things are going to be determined by what's on their permit, right? So when they have to discharge out into a river or a stream or a lake or someplace else out in the nature, into the ocean, right? whatever's on that permit is going to dictate whatever their treatment is going to have to be. So, every plant has probably felt the pain at one point or another of knowing that permits don't get more lax, right? They don't get less strict. They don't suddenly say, hey, you had 1 milligram per liter of phosphorus on your permit. Now we're going to just make it 5 for you. So they're more likely to say, how about we're going to make it like 0.2? And so then the plant has to deal with that, right? And so certainly there's a long process where they monitor, they maybe do plant upgrades, but eventually, instead of just monitoring, then they have to actually remove.
So as there's these ever tightening regulations or ever increasing community expectations, what's happening on that back end as far as monitoring analysis to kind of comply with all that?
There's online analyzers for many of the things that are on permits. So dissolved oxygen, organics of different things. So you can use UV absorbance sensors. You can use total organic carbon analyzers if that's something that might be on their permit. You can use total suspended solid sensors. You could use turbidity sensors or turbidity analyzers if that's on a permit. Nutrients of all kinds. So again, just like the things that could be monitored in the process, they can also be monitored at the outfall, which is, a really important thing. So they know immediately that, okay, if our permit is at 1 and we're now letting water out that's at 3 milligrams per liter of whatever our regulated parameter is, say it's phosphorus, say it's nitrogen or something like that, then we know that that's going to be a condition that we don't want. In addition to all of the other things that I've just mentioned, there's Hach has the Easy SC line. So what some people may be familiar with in the Easy series is this broad platform with many, many different parameters that can go from everywhere, from all of the markets that Hach serves: drinking water, wastewater, industrial applications, power and beverage and food and petrochemical, all the things I was mentioning earlier. But now we have the interface that's based on the SC4500 controller. So that platform is something that anybody that's ever had a Hach process sensor or process analyzer hooked up to, they will be familiar with this. The older versions were really cool. They did a lot of neat things, but the interface and the software was from a separate source. And so now we are doing something that's familiar to Hach customers, something people that know the menus, people that recognize what it is. You can see it from across the plant that it's an SC4500 controller, and the menus are a lot easier to manage. There's heavy metal analyzers for a bunch of different parameters: aluminum, zinc, iron, manganese, chromium, boron. There are nutrient analyzers as well on that platform. So nitrogen and phosphorus containing compounds. So it's a really cool thing we put out to try to make our customers' life easier.
Carlos, thank you for the conversation.
Good to talk to you, Travis. Thanks for having me.
Thanks for listening. If you want to support Waterloop's ongoing exploration of water solutions, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org.
You're in the water.